This is section 2.3, day 1. We're going to look at product and other trig derivatives. So the product rule deals with multiplication of two functions. Okay, and what the product rule says is the derivative with respect to x of some function f of x times some function g of x equals f prime of x times g of x plus f of x times g prime of x. Sometimes students like to see it without the function notation, so if you had u times v, it would be u prime times v plus u v prime. Okay, so I'm going to ask you to find the derivative. I'm going to show you how this product rule works. Example 1, if I have f of x equals x squared times sine x, you can see that there's two different functions here. So to find my derivative, the derivative of x squared is 2x, sine x stays the same, plus x squared is the same, but then it's times the derivative of sine x, which is cosine x. Okay. Look at another example. So g of x equals 3x times cosine x. Again, you can see your two different functions. G prime of x, the derivative of 3x is 3 times cosine x plus 3x stays the same, and the derivative of cosine x is a negative sine x, so sine x, and I'll change this to a negative here. Example 3, I'm going to give you a problem that could be solved with either the product rule or just the power rule. So for example, if y equals 3x squared minus 5 times 2x to the fourth minus x plus 1. Now it's a lot of work to do FOIL, so I'm going to use the product rule initially, and I will also FOIL it out and then just use the power rule. Derivative of the first function would be 6x times my second function. First function stays the same. The derivative of the second function would be 8x cubed minus 1. If I multiply everything out, I'm going to get 12x to the fifth minus 6x squared plus 6x plus 24x to the fifth, and I'm doing the second one here, doing FOIL, minus 3x squared minus 40x cubed plus 5. And what I was doing, I was just doing FOIL. So first, oops, outer, inner, last. Combine like terms. I get 36x to the fifth, okay, because I'm just putting my like terms together, minus 40x cubed, my x squareds together, minus 9x squared, plus 6x plus 5. Now let's use, I'm going to move over here a little bit, let's use just the power rule, so I'm going to multiply everything out. If I do that, y would equal, I'm going to do FOIL, so 6x to the 6 minus 3x to the third, the last, plus 3x squared minus 10x to the fourth plus 5x minus 5. All right. Power rule, y prime would equal, oh, before I do that, let's see if I can kind of rewrite this so that it's a little bit cleaner. So before I find the derivative, so it's 6x to the 6, and then I'm going to put minus 10x to the fourth, minus 3x to the third, plus 3x squared, plus 5x minus 5, just so that the powers are in order. All right, my derivative would be 36x to the fifth, minus 40x cubed, minus 9x squared plus 6x plus 5. Notice that it matches with our other answer. Okay, they are the same. And you can choose how you go about it unless it specifies for you to use one of the rules. A couple other trig derivatives we need to know. Is the derivative with respect to x, and we'll actually prove some of these tomorrow, of tan x equals secant squared x. Okay. And the derivative with respect to x of cotangent x is going to equal negative cosecant squared x. And then if we have the derivative with respect to x of secant x, this would be secant x times tan x. And the derivative with respect to x of cosecant x would be negative cosecant x cotangent x. Okay, so it's the same rules apply if you combine it together. So for example, if I gave you f of x equals x cubed times secant x, your derivative, you'd be using the product rule. Derivative of the first function is 3x squared times secant x, and then the derivative of secant x is secant x tan x. If you want to factor out a greatest common factor, you can see that they have an x in common, or x squared in common, and a secant x. So I'll be left with 3 plus x tan x. Okay, so let me know if you have any questions.